Hi everybody, welcome back to My Physical World, where we're continuing talking about our LiDAR images and how to use them in ArcGIS. If you remember from last time, we learned how to open up a LAS file, which is a LiDAR exchange file, and we opened up two individual ones. Then we combined those two individual LAS files into what is called a LAS data set using ArcCatalog. We created a new data set and then added the two individual LAS files and made sure that the statistics were there so we can mesh the two different elevation ranges in each panel together so they act as one. Remember, a data set doesn't physically combine your LAS files. It just gives pointers to those two files and combines the minimum and maximum elevations together so you can create a seamless 3D map of those data sets, those LAS files, okay? So what we're going to do today is just do a couple other preparations that you'd want to do with your LiDAR data to create what are known as rasters or digital elevation models and doing a hillshade. Okay, so here we have our combined LAS files, our LAS data set. In order to turn this into a digital elevation model, we need to convert it to a raster. So that's converting a LAS to a raster. And how you can do that is just go over here to your search bar and type in LAS to DEM or LAS to raster. And you'll see LAS dataset to raster here on this bottom one. So we'll click that, and that opens up a link to the tool, which is LAS dataset to raster. Double click that, and that opens up the dialog box. And we are going to choose for converting. Now you can convert individual LAS files into a raster, or you can do a LAS data set into a raster. And that's what we want to do, is we want both of these panels together so they're acting as one. So we'll select the data set that we created, and then I'm going to give it an out file, and we're going to go to Huron County LiDAR, and I'm going to call this our HC raster. Okay, and I'm going to hit enter. So we got our Huron County raster, and the value field that we're going to use to generate the digital elevation model obviously is the field elevation from that LAS data. Now you have two interpolation types. You have binning and triangularization. You can experiment with them both to find out which ones you like the better. But for my visualization, I usually do the triangularization, and I also do the method as linear. And I click OK, and it's going to chew on it for a little bit and create that raster. Now, since I only have two, I'm only using two panels. It doesn't really take that long. I have a pretty good computer. I mean, it's not a beast, but I currently have an i7 processor. I have 8 gigs of RAM and 3 video. Mine's a Dell XPS 17. It's a good computer. It's 8 years old and it hasn't failed me yet. So, all right, so it finished creating the raster, and that's underneath here. So we'll get rid of our top layer so you can see what the digital elevation model looks like that it created. All right, so now we have a digital elevation model. And for visualization, for making nice looking 3D looking maps, even in 2D space. Usually from this point, you want to do what is called a hillshade analysis. You want to, it's kind of like sculpting it and creating it, what makes it look like a hard-coated plaster impression of the 3D space. I like to do that just because it makes your maps pop, you know. All right, so what I'm going to do is, now that we have this raster, we have this digital elevation model, now we can create a hillshade. Our hillshade analysis will not, you cannot create a do hillshade analysis with a last data file or a last data set. It has to be a raster, and that's why we created the HC raster. All right, so next step, you can go back to search, and if you type in hillshade to get a quick link to your hillshade analysis from Arc Toolbox. So you have the spatial analyst hillshade and you have the 3D analyst hillshade. We're going to do the spatial analyst hillshade. So click on that link and it opens up in Arc Toolbox the tool that you need to use. So double click on hillshade. For the input raster, you're only going to have one choice, and that was the one that we just created. So go ahead and choose that. And then for your output, you select a location, and I'm going to make this HC hillshade, just so we can tell them apart. Click OK. The azimuth, sorry, the azimuth and altitude, you can change these around, especially for your geographic location, to mimic the real world sun angle. All right, I'm just going to use the default of 315 for the azimuth and 45 degrees for the altitude. So click OK, and then it's going to chew on this for a little bit, kind of like it did when it was creating the raster in the first place. Now I'm only using 2 panels, so it doesn't really take all that long. Again, so we'll let that chew on that for a couple seconds, and bam, now we have our hillshade. Like I said, a hillshade makes it kind of look like it's a plaster cast of your 3D space. You can do all types of analysis with a hillshade based on your sun angle and your altitude of the sun. But most of the time we use hillshade to do visualization, to make your 3D maps, this is kind of weird, your 3D maps in 2-dimensional space pop, you know, look really nice. All right, so here we have our hillshade, and we have our original last data set that gives us our true elevations. Okay, you can go in and double click your last data set, choose elevation, go to the display, and you can change that, your transparency to 60% or whatever you wanted to, and it kind of gives you a nice looking hill shaded 3D map. Now the other thing that you can do is, now that you have this raster, is we're going to move the raster up on top of the hillshade, and we are going to double click the raster, go to symbology. We're going to change the color ramp to something more meaningful to geography, and we're going to use this pastel elevation view. We're going to click OK just to see what it looks like. All right, so I'm going to double click that again because I want to go to the display tab and I want to change my transparency to 60%. And that gives you another type of visualization of your 3D map. Okay, and this This is using the raster image rather than the last data set. So let's turn let's turn the raster off and turn on the last data set so you can see the differences between the two, other than the colors, of course. Now, speaking of colors, if you notice down here, I use the pastel elevation template. I'm going to change my last data set to do the same thing. So I'm going to double click that. A last data set you can treat just like any other layer in your project. So we're going to go to symbology, and I'm going to choose elevation, and I'm going to increase the number of classes to, let's say, 20. And I'm going to choose my palette, which was that pastel elevation model. Okay. And we're going to hit OK. So now I'm using the same palette that I did for the raster, just to see what they look like, which would make the better map. Is it the last data set that looks better, or is it my raster that looks better? Okay, I actually kind of like the last data set. Okay, then you can make a nice looking map. Now, since these are in state plane coordinates, you can also, just like any other layer, you can bring in other data, such as your county roads in this particular case. You can bring your county roads in, and you can overlay your data and change the symbology and do other types of annotation with that. Okay, so today we did a couple other things. We added on to what we did the first video. We converted the last data set into a digital elevation model, raster, and we took that raster and did a hill shade analysis on our data for visualization purposes. So next time we'll continue and we'll do something else with this LiDAR data. Have a great day. See you later.